I've put all my data in. I always like to be safe. Before I click any calculations, I always scroll up to the first empty space next to the data. And then you're going to go menu. And it's kind of self-evident. It has to be statistics. It has to be a calculations we're doing. And we've got one column, but that doesn't necessarily mean one variable. I could have two columns, and it's still one variable, which is what we're going to do with the continuous data. I'm actually going to have two columns, but it's still one variable. Now, the variable here, actually, x here was something. We don't even know what this is. Number of dogs in various schools. Very Austrian, right? So discrete data. Just St. Gilgen.
Actually, in every other school in Austria, pets are forbidden.
Okay.
For teachers and students. So.
We know this is one variable because we labeled the first column x, variable x, where x equals the number of dogs, right? So one variable statistics, and there's only one list. Because I could have had an x variable here, a t variable there, a z variable there. There'd be completely different discrete lists, and I could have analysed all three lists in one go. Okay, so just one list, and the x1 list is x. The frequency list. Well, these are all individual items in there. So the frequency list, there is no frequency list. We just default to one. There's just one of each item there. And we are going to say OK. And then let's just go down here, and I'll tell you what they all are. X bar is the mean of that data set. Usually X bar is the mean of a sample. But this is kind of like a data set of so many things. So 41.9 to 3 sig fig. Sigma x, it's all of those variables added together. Sigma, to add together. Sigma x squared, square all of the numbers and add them together. Now that's going to be used in the next lesson that we meet when we work out standard deviation and variance. Okay? So we'll unpack what this sigma x squared is. But this is basically take all the x numbers, square them, and then add them together. Weird and bizarre. It will help when we visit standard deviation and variance. S of x here and sigma x here. So these two guys, we need to know the difference between them.
Standard deviation.
Okay? This little guy here with a hat, this kind of little circle and a hat, this is lowercase sigma. So the kind of the summation, capital sigma, summation, lowercase sigma, standard deviation. So this is the figure 20.1. 20.1 is the figure by which this data set is spread out. And again, standard deviation, we will discuss a bit more next lesson. There's an extra magic figure here, which we'll ignore for now. But there's two figures for standard deviation. The one that we're going to do is this one. This is the spread of all of that data. And spread about from the mean. So how far, on average, are those data points from the mean? 20.
Wait, so is it basically like... So
Yep.
From mean to max?
First, Anis. First.
So it's a deviation.
It's a deviation. So it's a deviation, so it's kind of how far, but standard means it's been standardized in some way.
Okay, so standard,
All right.
This is the standard deviation.
The standard deviation really is the figure of spread you would probably use in your biology, in your chemistry, in your physics, in every other subject that you'll come across. Standard deviation is such an important concept, we have a whole lesson on it next lesson tomorrow. Such an important concept. And how we form it. And then that will, do we not? Oh, Friday, yeah. And also, that measure of spread and deviations, that helps us with, do you remember the regression line? And minimising the squares. So it's all going to come together beautifully when we do the regression again.
Standard deviation is from the mean to the max, from mean to the min, and then edit these two together.
No.
No, it's basically mean.
No.
Every x
Guys, pause it for now. Just accept that if I have two data sets, one standard deviation is lower than the other, the data points are more closely packed to the mean, right? That's a measure of standard deviation. The specifics we're going to get to next lesson. N, number of items in the data set. Min, minimum. Q1,
interquartile range.
this is the lower quartile. So 25% of the data set is up to 24. Median, 50% of the data set is below 38.5.
Same as Q.
Beautiful. Q3, upper quartile. The top 25% of all the values are 61 and bigger. How good is this, right? How good is this? Does it all magically for us? And keep going. The max? Well, obviously max. These guys here, we're not going to look at now, but this will help when we start to do regression lines. How beautiful is that? Next, doc, insert, data and statistics. Click X.
With dot, insert.
Have a little look at that. Doc, insert, data and statistics. Yeah. And then click on the x-axis. There's the x variable. How beautiful is that? Yeah, so isn't that nice that we can now, we've got the median from before, we've got the mean from before, we can now very easily see the mode. If you hover over these bad boys, look, 24. 24 is represented 3 times here. So the mode of x is 24. It's magic, isn't it? But let's keep there, guys. Let's keep there. Are you ready for this?
I'm still.
Yep.
It's not working.
Is it not working?
No. Oh wait.
Did you doc insert data and statistics?
Yeah.
Yep.
What are you doing? Okay. I think we got it. Okay.
Yay, okay.
It's looking very. Yeah.
Beautiful, perfect. And now the magic, ready?
Thank you.
We're going to get 2 beautiful other representations. Menu, plot type, box plot. Boom! Look at that, guys. If you just toggle over it, 3 is the minimum.
Wait, dot.
No. Menu, plot type. I don't have box plot available now because it's already a box plot. I can go back to a dot plot. Menu, plot type, box plot. And look, you've got a summary of the data set. Listen to the language I'm going to use. Guys, if you want to look at the board here, 50% of the data lies between 24 and 61. The interquartile range, the spread of the middle 50%, is 61 minus 24, 37. The middle 50% of the data is spread over 37 things, whatever the units are. And all of the data set is spread over, how far? 76. The range. Range versus interquartile range. So this is not very nice, but sometimes quartiles and percentiles, the top 10%, the top 5%, this is now into exam-based structures, aren't we? You know, 7% of the world achieved level 7 in HL applications last year. Okay? So they're in their 93rd percentile and above is the language we would use. Okay? If you're at the 100th percentile of something, you're literally in the top 1% of a whole data set. One more graph. Menu, plot type, histogram. Oh, nice. But there's something a little bit naughty here because if I have a hover over that biggest bar here, this is from 20 to 25 and there's 4 points on there. But that's okay, isn't it? We've decided to group it from 20 to 25. So we can choose the lower boundary of our grouping and the upper boundary.
That makes it a continuous.
Exactly. So the problem with going to histogram is this, that if you've got a discrete data set, you should technically maybe have little gaps between the bars. But you can make it with no gaps between the bars. But this doesn't really represent it. Let me show you how I'm going to change this. And this might help with the continuous one for sure. Menu, plot properties. Menu, plot properties. This is a histogram, right? And I'm going to go to the bin settings. I'm going to go to equal bin width. And the width. Now this is how you choose how wide your categories are. Okay? This is definitely good for continuous data, isn't it? Because that would make sense. For this data, I'm going to choose 1.
So it's singular.
Yeah, but the alignment, do you remember what the smallest value was?
3.
3. So I'm going to do 2.5 here. So think about what's going to happen now.
It's going to start from 3.
Shrink.
It should hopefully now just reproduce the dot plot that I had, right? Make sense? So I'm just showing you all these tools. Now, the histogram tool on the TI-Nspire I never use.
No.
Because there are better ways of drawing a histogram if you're doing some kind of project-based maths work. All right? And in any exam, I don't think you'd need the histogram feature. But it's there, right? Usually a histogram is to represent some data, you're publishing something, you're doing a little exploration in mathematics, you want a histogram to show the data. I'd probably do it on a different software package. Excel. Why not? Google Sheets. Yeah, something else. I think it's better.
It's easier to change the data.
Yep. But for this guy here, if I go back to menu, plot type, box plot, I use this feature a lot from the TI-Nspire. Because drawing good box plots on other software isn't so easy. Drawing a box plot on Excel is remarkably hard. And students who have done some kind of maths IA work, they've kind of screenshot this and then pasted it into their maths document. Okay.
But how can you screenshot?
Easy, watch. Shift, Command 4. The crosshairs come on.
No. Well, that's on the laptop.
That's on the MacBook.
Yeah.
Oh yeah. Yeah,
Yeah,
on the MacBook I didn't have a quick shortcut.
And then I can just paste it into a document here. Whoa.
I'm gonna get the digital version of the Inspire.
Yeah, because it was
Oh.
supposed to be on the box.
It's on my desktop, I think. Let's have a little look.
Yeah, it is.
There you go. So it's on there. I can just drag it into my document, okay? But even on PC, you can still do, you should be able to do print screen and then crop, okay? So just finishing off here, guys. That's pretty much it. That's the power of the TI-Nspire to perform all of those statistical calculations in an instant. So measures of average, mean, median is from the spreadsheet. Mode for discrete data, menu, plot type, dot plot. Mode is pretty much from that, right?
Yeah.
And also we can do a beautiful menu, plot type, box plot. This now allows us to do the measures of spread, dispersion, range and interquartile range, how the whole data set is spread, how the middle 50% is spread. And then the other measure of spread comes back from the spreadsheet, the standard deviation in here.
Oh, what is the variance?
So the variance is just the standard deviation squared,
Oh, so it's just 20.1.
20.1 squared. So those magic numbers form our lesson on Friday, really unpacking where the heck does standard deviation and variance come from. Okay? Between now and Friday, because we've just got the 5 minutes left, right? Between now and Friday, what I'd like you to do is, first of all, pause the video, because we don't need to keep going there.